and welcome to Teacher Gimble's channel. Today I'll be going over Geometry Unit 1 Lesson 19 practice. If you like this video, please make sure to like and subscribe by pressing the button over here. And if you want any other lessons that are not posted or personalized videos on any math topic, if you look at my bio and go to my Patreon, you can subscribe and I'll make you whatever you need in the next few days if you just let me know. All right, let's get started. Problem 1. What is the measure of angle ABE? So first thing, ABE, we want to know this guy right here. So if we have angles that are across from each other, they're called vertical angles, and they are always the same measure. So this is 40 degrees. And we're done. Let's go on to the next question. Select all true statements about the figure. So let's zoom out for this one. And this is going to be one of our first proofs we're doing in geometry for this unit, which is exciting. Is C plus B, so C plus B is going to be this angle plus this angle, which I immediately know is going to be equal to 180 because they lie on a line. And I always think if I can draw a semicircle, the angles that are inside of the semicircle always add up to 180. Is that equal to D plus C? Well, D, let's change colors, is right here, and C is right here. And I see that's also a semicircle, also 180. So they're equal. Yep, it's true. Is D plus B equal to 180 degrees? So D, let's erase what we have on our diagram because that's going to confuse us. We have D plus B. We don't know anything about D. We don't know anything about B. They don't lie on the same line together and make a semicircle. So this is not a conclusion that we can make from this diagram. C. Rotate clockwise by angle ABC using center B. Then angle CBD uses the image of angle ABE. So we're going to rotate the whole figure, I'm assuming. We're going to go clockwise. So clockwise is that direction. Where the center we're talking about is center B. So we're going to rotate by angle ABC. Is angle CBD the image of angle ABE? So we're going to rotate this angle, CBD. We got to identify everything. So is CBD the image of angle EBA if we rotate by that angle? Well, to get CBD to be the image of EBA, I believe we would need to rotate 180 degrees because this side would have to go all the way to that side for this to line up. So when we're rotating by angle ABC, that's not 180 degrees. So no, this would not be true. But hey, rotate 180 degrees around center B, then angle CBD is the image of EBA. Yes, this one works because we had to rotate it 180 degrees around the center. So sometimes it takes a minute to get situated with the problem, but it's always worth it to take that time to do that, to get situated and figure out what your image is, because it's going to help us in further questions. E. We are going to reflect across the angle bisector of angle ABC. So ABC is this angle over here. An angle bisector would be right about over there. And he's going to come straight down. And then angle CBD is the image of angle ABE. I believe, yes, if we had an angle bisector, this would line up, this angle would line up with that angle because they're going to be congruent when we do that reflection. This angle would line up with that angle, or this line would line up with this line because they're going to be, when we reflect it over that line, these two angles are congruent, so the lines line up, which means this angle will match up with that angle. So yes. And then F, reflect across line CE. So CE is right here. We're going to reflect across, which means AB is going to come down over here, and DB is going to come up over here. This will be A gets pushed down here, D gets bumped up there. Is angle CBD the image of angle EBA? CBD, EBA, no, that does not take this angle and put it over here. It just shifts them kind of down over there, but that does not make the angle. So that one is incorrect. All right, let's go ahead on to the next question. Problem 3. Point D is rotated 180 degrees using point B as a center. So 180 degrees, it doesn't matter which direction. It looks to me that he lines up with point A. Explain why the image of D must lie on the ray BA. Well, B is on BA, and when we rotate a line 180 degrees, when D is going to go ahead and line back up on point A. That proves this is true is we're taking this segment and we're rotating it 180 degrees to kind of figure out where point B is, and we know 180 degrees is going to always make a line. So it keeps it onto the same line segment. A line has a measure of 180 degrees, and I always kind of put 180. So you can remember that. All right, so a line segment, if we're going to measure it, is 180 degrees. So when we rotate a point, it's going to end up 180 degrees. It's going to go back on that line segment because of that fact. Problem 4. Draw the results of this sequence of transformations. We got a very busy shape down here, but we're going to figure it out. Rotate A, B, C, D. A, B, C, D. So we're looking at this figure using point D as the center. So we're going to rotate the shape clockwise. So we're going this way. We're using point D as a center of rotation. And the angle that we're rotating by is ADC. So it looks like it's about a 90-degree rotation, which means AD is going to come down kind of over here. So A comes over here, which is going to bring B over here, which D is going to stay where he's at. And so C is going to be right about over there. And that looks a little wonky, but I think this is what we have. Now we have translate the image by the directed line segment DE. The directed line segment DE is over here. So we're going to take the whole guy and we're going to bring him right up over there. And that's going to be our translated or transformed figure. I would recommend if you're doing this on a piece of paper to use tracing paper. This is a general sense of where it would be. And we're going to put A here, B here, C here, and D over there to make sure that we always, and we're going to put primes because this is our image, but always make sure to label your points. But go ahead, use a piece of tracing paper to do that rotation so you can get a perfect image on your sheet of paper of what it looks like. Problem 5. Quadrilateral ABCD is congruent to quadrilateral A prime, B prime, C prime, D prime. Describe a sequence of rigid motions that takes A to A prime, B to B prime, C to C prime, and D to D prime. Okay. I am going to think about what works well. I know D prime, C prime is going to line up. So I'm going to take C prime. Well, I'm going to take C, I guess, because we're going C to C prime, and I'm going to drag him all the way so he lines up. So my shape, C is going to go over there, D is going to go here. We're going to have B all the way down here. We're going to have A over here because they all got translated by the same directed line segment. And then I'm going to rotate him 90 degrees clockwise around point C. 90 degrees clockwise around point C in my 3 facts. And he's going to line up. So we translated and then we rotated and we got A, B, C, D onto A prime, D prime, C prime, D prime. And we're done. Let's go on to problem number 6. Triangle ABC is congruent to triangle A prime, B prime, C prime. Describe a sequence of rigid motions that takes A to A prime, B to B prime, C to C prime. So I'm going to do a very similar thing what I just did. I'm going to take A, I'm going to pop her on A prime. Now our triangle has shifted over, just like this. Then I'm going to rotate. I'm going to estimate 80 degrees clockwise. If you have a measuring tool, I would go ahead and measure that angle. C is going to get dragged down to C prime, B is going to get dragged to B prime, and our shapes line up. And we're done. So use tracing paper if you have tracing paper to be more specific, but we just dragged and we rotated and we are finished. Let's go on to problem number 7. In quadrilateral BADC, AB is equal to AD, AB is equal to AD, BC is equal to DC. The line of symmetry, AC, is a line of symmetry for this quadrilateral. So we have AC is a line of symmetry, which also means that if we reflect this shape over, this angle would line up with that angle because the line of symmetry is the same thing as the line of reflection, or it's always the same line as the line of reflection. 1. Based on the line of symmetry, explain why the diagonals AC and BD are perpendicular. Well, AC is this diagonal, and DB is going to be this diagonal. And we know the line of symmetry can serve as a line of reflection, and B gets reflected onto D. And the line of reflection is always perpendicular to the line that connects the two reflected points. So the diagonals, if it creates a perpendicular bisector, because this is the line of symmetry, is going to create that 90-degree angle because we're dealing with reflections. 2. Based on the line of symmetry, explain why angles ACB, so ACB in this case is ACB is this guy, and ACD is this guy. Well, this angle got reflected on top of this angle over the line of symmetry, which means that they have to be congruent because reflections preserve angle measures. Symmetry is reflections. And so therefore these two angles have to be congruent. And we're finished. Problem number 8. This is our last question for this. Let's zoom out. Here are two polygons. Select all sequence of translations, rotations, and reflections that would take polygon P to polygon Q. So P is going to Q, and it's always important to identify the image and the pre-image. So P goes to Q in this case, and let's change colors so we're not the same color as the graph. Reflect over line BA, so I'm going to sketch. And initially, I'm going to do a sloppy sketch because they're a little bit quicker. I just visualize it, and if I think that I might be close, I might redo it in a neater sketch just to double check my answer. So we're going to reflect over line BA. So when we're reflecting over line BA, it's going to kind of come down something like that. Probably a little smaller, but look something like that. And then we're going to translate by directed line segment CB. So CB is here, which means this whole shape is going to come down in that direction, which does not put them on top of Q. So A is not correct. Let's check for B. Translate by directed line segment BA. So everything's going to slide up that much. A is going to go here, B is going to go here. Everything slides up kind of a similar manner, which drags them over here. And then reflect over line BA. In this case, BA has moved up. So we are going to reflect over that line as it's been moved right over here. So we reflect it over, which is going to bring P onto Q. So this is correct. C. Rotate 60 degrees clockwise around point B. So here's point B. Remember, I always say we're going to rotate that direction. I like to think of one segment. So this segment, he's going to come down over there when we're rotating around point B, and it's going to drag the rest of them with them. So this segment kind of goes down like this, which means it goes down like this, up, down, something along the lines of that. Always label our points. So this would be A. This would be C. E goes over here, and D goes over there. And that's an estimate. And then translate by directed line segment CB. No matter how I translate this, it's not going to be oriented the right way. So I can immediately cross that out as one of my answers. And then two more. Translate so that E is taken to H. E all the way to H. Okay, so we're going to end up with, it's going to be oriented the same way. So it's going to look something along the lines of that. That's quite ugly, but that's okay. And then rotate 120 degrees clockwise around H. So we're going to rotate this direction around H, and 120 degrees is not going to get us where we need to be because this point's going to have to go all the way over there. This is going to get dragged over there somewhere. So nope, that is not correct. And let's check F as our final answer. Translate so that A is taken to J. A goes to J. Ooh, I like it. So this whole guy slides up in that same distance. Each point is dragged up the same amount. And then reflect over line BA. Oh, we reflect. Yep, this one looks good. All right, if you like this video, please make sure to like and subscribe, and I will see you in the next one.